to take the opportunity to welcome everybody for joining us today. Greatly appreciate it. Today, the topic is about talking with the experts, and the topic is designing at the age of rapid prototyping. I had prepared the page with Mihir's information and John last, but we have somebody else actually replacing John. Mihir, if you wouldn't mind, could you take a minute and tell us a little bit about your experience and a little bit about you, please?
Sure. So I am an electrical engineer. It's hard to say former because it's something that's like a practice for life. So I was an EE hardware designer. I worked at Tesla and Axon, which used to be called Taser. So I actually worked on the Taser weapons and the power electronics inside there for a little bit of time. And then I came over to the manufacturing side because Royal Circuits and a few of other businesses that we have in the space is actually a family business that my dad started. And it only made sense for me to come in after I'd been the customer and see how can we make PCBs something that are fast, efficient, easy to design, let everybody kind of be really in control of their own designing destiny. So that's what we're working on over here at Royal Circuits all the time. And again, my background is in electrical engineering, mostly power electronics, analog circuit design, and then some kind of embedded systems depending on the different projects that I've worked on. And a lot of Eagle experience for all sorts of boards, regardless of the company that I worked at and their preferred CAD tool. I found myself designing so many of the manufacturing testing boards and any other small circuit or add-on or whatever, I'd always be designing in Eagle. So I've had a lot of experience with Eagle and I've been using it for a long time. Great tool.
Yeah, actually, I would dare to say maybe like 10 or 15 years ago, I was contacted by Royal Circuits because they were getting so many files from Eagle. They just wanted to see what could we do to make the process faster. And we went through the whole DRCs and DFMs and so forth. I remember that. I worked with Milan with that, I would dare say like 15 years ago or so. So yeah, we've been working with Royal Circuits closely for a very long time. So let's just tell you a little bit about Royal Circuits. Well, Circuits has been around for approximately 20 years. And one of the nicest things that Royal Circuit has to offer is that you could download the DRU file for Eagle. The DRU file is what is going to be controlling your design rule checks within Eagle. That's what's going to determine your distance parameters, your clearance parameters. You could actually define your layer stack up. That way it's controlled by this DRC. So it's actually pretty neat that they actually offer it on their website. So you could just visit their website, just go to royalcircuits.com, and right off the bat, you'll see where they have the Eagle DRU file that you could download, and it could be easily loaded in Eagle. Okay?
Yeah, and yeah.
Also, I just wanted to let you know about the most recent projects that Royal Circuits actually did for us. This is two of them. One of them was for the one on the left, as you could see there, was a fidget spinner that we rolled out. And people actually we had two reflow ovens. And Royal Circuits made those boards for us, and then we had a template. We had a stencil, and we actually would put the solder paste, and the users would actually place the components. They would go through the whole process, see how it goes in a reflow oven. We would upload the software, and they could actually walk away with a spinning fidget. This file, as well as everything else, will be soon uploaded to our website for those of you that are interested in making your own, as well as a personal project. And the other one is a air quality sensor, which is the one on the right. This was actually made by Royal Circuits as well. You made a big run on this. I remember, if I recall correctly, Mihir, you guys did several thousands of these.
Several thousand, which isn't even necessarily our niche, but our niche is quick turn. So whatever you say, we're still going to try to push it out in like 1 day.
So yeah, and I remember when you walked up to the booth, we plugged it right in and it worked. So that was pretty awesome. Appreciate
that was awesome, yeah.
So I'm just going to go ahead and stop sharing my screen and let's listen to Mihir. Ed Pataki and myself will be manning the chat. I've stopped sharing my screen here. You should be able to get the capability of sharing your screen. That way you really go through your slides and you can tell us a little bit about techniques and your idea that how should we go about it to avoid respins and getting my prototypes done. So I'm going to go ahead and mute my mic until you let me know. Okay. Thank you, Mihir. Appreciate it.
Sounds good. So can you see my screen?
I do. We see your screen. Yes, we do.
Great. So yeah, the purpose of this presentation and of this discussion really is to talk about how do you avoid respins, and really that starts at the design stage. Garbage in, garbage out, but at the same time, if you send in clean stuff, oh my God, it can make a world of difference in terms of your speed, your time, your quality, and just how quickly we can get things on the production floor and through the production floor without any issues. Like Ed described briefly, we're purely a quick turn shop located right here in California. We have two factories over 50,000 square feet doing fab for rigid flex, and rigid boards in the Bay Area and Los Angeles. And we build boards for pretty much every company imaginable at quantities ranging from one to the low thousands, like Ed we did for Autodesk recently. But our real niche is in the super quick turns, low volume. You just need a few boards to test out your circuit like tomorrow, and we're hustling to get that done with a couple hundred employees over 3 shifts, run 24/7. Even Elijah's up till 8 p.m., etc., answering calls and just handling any problems we have with CAM and tooling, pre-processing, all the way through production. So we're always running and kind of always there for the customer, and that's just the way it goes in the quick turn industry. So we're going to go into a little more in-depth in the technical stuff on things you should be looking out for in your designs. And we also have a layout service, and Eagle is our preferred provider as well. So we own and run PCBlayout.com, not Royal. It's a separate thing that I kind of run as well. And we only bring it up just because a big part of all the learnings that you'll see in here, those are things that are innate to our own design philosophy, and we guarantee that you get stuff that's 100% manufacturable the first time around to save you cost and time. So let's get into it. So in general, most people's design goals, as you design any sort of product, especially in electronics, it has to be manufacturable. Somebody should be able to make it. You want to make it as cost effective as possible, meaning not just the fabrication, but also the parts that you're choosing and the assembly and the time and the shipping, etc. You want to make sure it's done as fast as possible while still being manufacturable and being cost effective. And then lastly, you want to make sure that it's scalable. And scalable not just in terms of quantity, but also in terms of other people being able to manufacture it too. Oftentimes, there are certain jobs that certain shops are the only ones that are able to make it for really tough designs. But largely, if your design can be kind of manufacturer platform independent on a technical scale, that'll help you a lot, especially when you go shopping. So broad overview, the routine practices and things that you're going to find that you need to do or you should do every single time you're designing a new product is being able to provide the correct and right information up front and choosing your manufacturer wisely. And this picture on the right is an example of a fab print, essentially, that customers will send. You don't have to do this, but it has, Elijah, go into what you see regularly for fab prints that customers send in.
Yeah, this is basically the blueprint of everything that you want. And what I'm going to look for right here when I'm starting a job is my board thickness, the color of solder mask that you want, the copper weight that you want. If you have a specific stack up that you want us to follow, there's a great time to put it here. Drill charts and counts. Again, this is everything I'm going to reference to. If there's any mismatch whatsoever, that's where things can start to go on hold.
Yeah. So even though your design file has a ton of information about the actual fabrication of your board, there's some things you still need to actually write in, like some of your preferences, like what solder mask color do you want? And what is the final stack up and board thickness? And if you don't say anything, what's normally going to happen is it's assumed that you want to go with our standard stack up. But sometimes for a more complex board, we're still going to have to refer and ask you about it. So that's kind of the overview on the broad routine practices, and now we'll go into them. So to start, giving the right information up front is incredibly important. And you'd be surprised, or maybe not, Ed, at how many people don't actually supply all the right files. And just that communication lag and that kind of lack of information can cause a lot of unnecessary holds that have nothing to do with the actual feasibility of manufacturing your design, but we just don't have certain items and we really aren't in a position to make a lot of assumptions about your board, or we'd rather not. So we need to go back to you, and then you're like, oh, it was kind of obvious, do X, Y, Z. So if you provide that information up front, it's a lot easier. So we kind of listed it down for all the different parts of the design and manufacturing process, what you need. For fabrication, you need to send your CAD CAM files So you could just send your native CAD file, like your native Eagle files, and we can generate the Gerbers, ODB++ files from them. But if you want to send the Gerber files themselves, that's fine too. And then your fab notes. If you have any other specific additional notes that you'd like us to be mindful of, or if you have any other questions, just send those at the time. It's better to send more information than less. And then we can go from there. For assembly, same deal. We want your actual board files, and then we need your complete bill of materials, which we'll go into later in what constitutes a complete BOM. And then your XYRS file, which is really your pick and place placement file. And the reason we need that up front is that right away at the quote stage, we're going to do a full design for assembly check and basically ensure that all your parts are placed and rotated correctly on your board. The footprints you've designated on the board actually match the footprints on the part that you've relayed in the bill of materials, which is more manual. And then also that all the rotations are correct, the pin 1 locations are correct, etc. So that's for assembly. And then for PCB layout, really what you need to start is you just shoot over your schematic. Parts libraries can generally be extracted from there, especially in Eagle's case. You just send over your schematic and your mechanical outline if you have it or want it. And then we pretty much just do the whole layout for you from there as well. And most design firms are pretty much the same as well if you outsource any part of your design. So now getting into, I guess, the more technical parts of board fabrication and actually designing for manufacturability, which is something that I certainly did not learn in school studying EE at all. And I really learned more of it through trial and error. And then after I joined the actual fabrication side of the business as well. And so Elijah's going to have a lot of good tips here, and we're open to, Ed, as far as the chat goes, we're open to having a back and forth discussion, or would you prefer that we go through the whole thing and then go to and have a Q&A session?
So if I see any question that is in concern, I'll go ahead and kind of like interrupt you, because that way you don't move on to the next slide, and we'll just cover those as I see them come in.
Cool. Sounds good.
I had one question from the previous slide, if you don't mind me asking me here. Now you're talking about the XYRS file on the PCB assembly. Is there any particular format you want that? You want that on a spreadsheet, or can we just export it from the one of the ULPs that we have in Eagle? Or
yeah, you can export it from a ULP in Eagle. I don't have the specific answer on doing that, but I guess I could find a way to send it. When you send it out, everything out to everybody, we'll have a nice
yeah,
okay, how to generate that XYRS
just
file.
to let you know.
Online.
Excellent. Yeah, it's called mount.smd.ulp. It's like a comma delimited file format, and you could send that out. That puts the name of the component, the X and Y, all the coordinates and everything. That's one way of doing it, and it works really well. That was the only question I had. I didn't know if you had something specific, but we could always work with that mount SMD as well.
Generic and that type of file is totally fine. That's what we get from most people, and that helps us essentially set up the pick and place and also do our full design for assembly check while we're doing the DFM check as well. So we're just ready to go for a full quick turn, 1-2 day fab, 1-2 day assembly. Like that's the stuff we're talking about.
Okay, cool. So yeah, that covers the.
I did have a quick question, if I might, if I can jump in there.
Yeah,
go ahead, Ed, please.
Yeah, I just wanted to know, so if you do an assembly job, do you prefer to procure all the parts yourself and you just want the BOM, like let's say a list of DigiKey parts, or sometimes I've had projects where I've had to get parts from all sorts of different distributors for, motors and, all kinds of different things that don't always come from one distributor. And so I wonder if you also will take a box of parts that the customer can ship you and say, okay, for this job.
Totally. That's a great question. And the answer to that is either works. And we actually, through our assembly partners, but we have some preferred partners that we work with, we've developed a lot of internal software with. We actually accept cut tape, meaning you can literally send us a baggie of 6 ICs that you want placed on a few boards with the information listed in the bill of materials. And we have our own system with laser cutting and trays. We don't even need to buy big reels from other people. So you could send us parts if you have a special group of extra parts laying around that you still want to use, or if you're able to source them at a better price or you already have them for whatever reason, you could send those to us. Or we have our own sourcing and consignment team that we can do to source all the parts. And we have our own kind of special avenues through DigiKey because we do so many unique so many unique part numbers, such a large volume per year. We're able to do that at a special way through DigiKey that general consumers are not able to. So if you send us your bill of materials, it's probably faster if we buy all the parts for you and just, kind of send you the quote and the price, and you can just do that afterwards. Or you can send us parts or a mix. We're super, super flexible. In general, with our business, with the quick turn, you will find very little bureaucracy. You'll find a lot of flexibility and a lot of willingness to kind of work with what works for the customer, because we're not doing 5 million units with 20 project managers for one particular design. It's like 50 different designs per like 3 hours. I mean, it's nonstop.
That's great. Thanks.
Did that answer your question? Did that over answer it?
No, that was perfect. Thank you.
Yeah, so we do whatever, but we have our own way to do it. You can send us cut tape, reels, whatever you want. Should I move on?
Yeah, go ahead. Go ahead. Move on. You bet. Thank you, Meher.
Sure. So now we're going to get more into the specific DFM, especially as it relates to actual PCB design and manufacturing. So at a high level, and we have a bunch of slides going deeper into all these things, but we're going to talk about the copper trace width and spacing as it relates to the actual copper weight. That's one of the most important things that Elijah says he sees on 99, 100% of designs, some sort of issue or some sort of consideration he needs to double check. The idea of running the DFM check in your CAD package to the best of your ability for your design and your fabricator. And that's something that we talked about earlier with Royal having the DRU, the design rules for Eagle specifically for our basic and our advanced spec up on our website that you can go download, and that'll send that out with the final information, everybody. Inner and outer clearances for edge clearance, and as far as close trace and space and pad and drill and annular ring, etc. The idea and concept of a fabrication print and what makes a good one. And then just some general information on stack ups. What material is available? What's a good stack up? Do you need to have a stack up for every single design ready? Can you use our standard stack up? And can we help you with your stack up? Which the answer to all of which is yes, 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 and yes. So let's get into it. So I'll let Elijah kind of handle this one and what he sees and why it's important and what it means. So take the floor, Elijah.
Yeah, so this is a basic, I guess, spreadsheet that I use at my desk. I have it hanging on my wall. I use it every single day, every 5 minutes. And I encourage you, we can get this to you, no problem. But basically on your left column, you got your copper weights. Very next column is telling you what our very minimum tray size that we can do with that copper weight. And it's basically the same whether it's inners and outers. We can do a little bit better on outers, but here's our basic standards, right? And same, very next column is telling you the minimum space that can go with that trace. We're also letting you know basically why we're doing that on the next column, which is how much we're edge comping, how much we're increasing the original trace you gave us, so that after all the etch process and production, you're going to finish at what you asked for. And the last column is probably what's going to help you guys the most. It's your Gerber files, what I want to see when it comes from you. I want to see, if I'm working again with the 1/4 ounce copper, I want to see a 3 mil trace, 3.5 mil space from you, and I'll be able to make it a 3 mil trace with 2.5 space. So you can follow that entire list. We go up to, I think, 6 ounce or 7 ounce copper in-house. Anything else can be ordered, no problem. But here's a basic chart. It's perfect for anyone starting out if you're unsure of maybe what you can do with the copper weight that you're asking for.
Yeah, and if you have any questions, you can reach out to Elijah and the team directly with any sort of engineering question. No problems at all. So what's the best email to reach you at for that?
Yeah, that's just Elijah at Royal Circuits, ELIJAH at Royal Circuits. And yeah, you can talk to me directly, and we have no problem answering these questions for you.
Yeah, and like he was saying, we stock up to 6 ounce copper, but in our shop, we built over 20 ounce copper boards. And you can imagine how big the trace is going to have to be with that thick copper, because when you etch, it etches down at an angle. And if the traces are too close together, you're going to etch, and essentially they're going to touch before they can get down to the bottom of that kind of copper layer. Yeah. So that's a big reason of why you need to have a certain amount of space. Etching does not happen perfectly vertically. It always happens at a slight angle. And so you're going to run into each other if you don't have the appropriate spacing in between them. Right. So that's what we have on trace and space. Do we have any questions on that?
No, we're good right now, Meher.
Cool. So moving on, this is just kind of a topic on BGA spacing especially, but mostly on what kind of vias then you're going to have to look into and what that means depending on how tightly your spaces are. So
right. So if we're looking at this BGA design, you're running traces in between those BGA pads. The minimum that we can do on your basic standard board is going to be 3 mil trace, 3 mil space. That's just going to help our etching process. It's going to just fly through the shop, no problem. Anything smaller than that, and what you're going to want to consider is something like a blind via. So you're going to want to take that pad, drop it down, and have that trace going into another location through your inner layers. And all of a sudden, you've created all this space on your outer layers. You don't have those traces weaving in and out of those BGAs anymore.
But why is the blind via important? What implication does it have? Like, why does it make things a little more difficult? Or not really difficult, but what does it change in the manufacturing process, if you were to explain it to them simply?
Yeah, as far as the manufacturing process in blind vias, it does change up your stack up quite a bit. It's not as much as thicknesses, but we have to build it a certain way, where we're basically, instead of making one big sandwich, we're making a small sandwich, making it a bigger sandwich, and then making it another bigger sandwich. So it does complicate things a little bit, but I think we've got a really good process narrowed down for that. But essentially, your biggest advantage to that is being able to fit tighter things in tighter spaces.
Yeah, basically we have interim drill cycles as well. When you have a blind or buried via, you can't just build the whole thing up like you're saying and then drill down full through hole with everything nicely stacked up.
Yeah.
You have interim drill processes. So not only do you need more time on the drill in between, but you also have to have another set of lamination cycles potentially. And then you also have to have, you have to be mindful of other issues like, what's it called? Like line up and alignment and everything else as you go through the manufacturing process, which isn't a problem for us, but it is a consideration how we tool and plan the job to run in the shop. And with more time and more people and more time on equipment, the cost for blind and buried vias does increase the overall cost of the board by a relative amount. That's not too great and depends on the complexity of the board, but that is something to be mindful of. It's nice in your CAD package to be able to make everything line up and make it look beautiful, but sometimes some of these things can really add cost and time to your design.
Yeah, and again, if you're going to consider running a blind and buried via, or you got something tight going on, give us a call or an email, and we can always help you out in figuring out what's the best thing, most cost-effective thing for you.
Yeah. So moving on, this is just another issue that we saw that I don't think is really well explained a lot of other areas on the minimum actual solder mask dams. So, Elijah, you want to go into that one, kind of what we're seeing here?
Yeah, something we see a lot is gang mask, solder mask. Basically, you're covering 4 pads with one big mask clearance. It's going to expose them all. There's no dams of your solder mask in between them. It's not very good for manufacturing or assembly. It's harder to put parts on without bridging gaps, basically causing shorts and stuff like that. So we do our own checks in our DFM before your board hits production. And we're trying to create basically 4 mils of space in between each pad. Just because, again, you don't want your soldered paste or actual lead to be bridging those gaps. And that's something we check for at a very minute level on every layer of every board.
So I'm assuming what's going on is that the solder mask is being so big that it overlaps each other, so it creates that bridge then.
So this is actually when the solder mask is clearing a huge gap and there's no solder mask between those pads.
Yeah, okay. So instead of being 4 independent one, it looks like one big one all exposed together then.
Yeah, exactly.
And then so then when you either use a reflow oven or something like that, it could shift, they could bridge and so forth.
Exactly.
Okay, I understand. Okay, cool. I don't have any questions on that one. And just to let you, I just wanted to clarify really quick because I know we have some brand new users. A blind via is a point. It's when a trace transitions from one of the outer layers to one of the inner layers. Okay, that's a blind via. And a buried via is when a line transitions from an internal layer to another internal layer. I just wanted to clarify that really quick because I know we have some first-time Eagle users. I want to make sure that they understood what's the difference between a blind and a buried via.
Yeah, and just to briefly reiterate, that can add cost to your process and a little bit of time, but more cost than time just because you're no longer able to just build the whole stack up in the sandwich of that is your PCB all at once and then drill all the way through like a nice through hole. You now have to do interim drill cycles, which means you still need to save time on all your drills. You need to have people working on them. You need to have more alignment and shifts and just other things to be mindful of as you develop a more complex and sensitive board.
So it's not common to use that method to prototype. Usually that's something a bit more on the manufacturing side, and the whole idea behind that, as I already had stated, was that it makes the board smaller, but it does have certain degree of difficulty when it comes to testing it out. Just want to mention that. Okay, so
yeah, that's right, because you can't see a buried via deep inside, right? There's no way to really test that thing out. But I was saying, as far as like, we're pretty much strictly a prototype shop, but we have blind buried and stacked and staggered microvias with our laser like every single day. So you'll see a lot of complexity for even designs that are meant to be relatively simple in terms of their actual circuitry. So this is a little more of an inside look in what now you can actually see what the blind and buried vias kind of look like. And this is more on the topic of via fill. And what they look like kind of internally and what makes it good. So I'll let Elijah kind of go briefly on what we're seeing with via fill, why it's important, and then maybe some information on what's going on with the pictures here.
Yeah, so via fill is another process that we offer, basically filling your via holes with either copper. We can also do an epoxy, non-conductive or conductive. So that very first one, we're looking at a conductive via fill. It's basically, we're going to call it a plastic. It's like a glue substance. We fill it up. It does have some conductive values to it, so you're still getting your solid connection. And we're gonna push it through the holes, hopefully with no air, and bake it, make it solid. And there's also non-conductive, which is it's really protecting your holes. If it's something like a really complicated or intricate design, you're gonna want to protect the insides of your guts, right? You don't want copper to start building up or rusting inside, or depending on where you're putting your board, right? And then that's just basic ways that we can fill the via holes. Then you look at that bottom one, that's the perfect example of a blind via. So you can see that that hole is only going through the bottom to about the middle of the board. It's not protruding out the other end. So you're still getting the connection you want, but you're getting more solid thermal connection on your inners. It's not compromised by going all the way through the board.
So what do we look for in a blind or buried via? Are the tolerances any different? Do they need to be mindful of other issues as they design them in, or can they just kind of drop them like any via and adhere to the general rules, which are the minimum drill size and the minimum annular ring, like kind of the ratio in between those two?
Right. Annular ring, all those rules are going to stay the same as any other hole. It's just on our side, it's really going to change the way we're going to build the board, whether we want to start with core construction or foil construction. That's more production stuff. But if you give us a little bit more wiggle room, we can make other things happen. Whether it's, sometimes we even get boards where we're seeing blinds and burieds being used, and we're realizing it wasn't necessary. We can contact the customer and say, hey, your job does not require this. Let us fix your files, do some plated through holes, and keep things running smoother. Cheaper for them, easier for us.
Yeah.
I have a few questions. I mean, here, John is asking, do Royal Circuits inventory any Rogers PCB materials which is used in RF circuits? I'm not.
Yes. So,
go ahead.
Sorry, was that it?
No, that's the question. Yeah, that's it.
Yeah. So as far as a lot of shops go, and we'll go into this towards the end on how do you pick your manufacturer. Part of that is business health, but a part of that is also having the capital to actually put in a stock room and stock a ton of inventory. We stock our material stock rooms worth over $1 million just sitting there at all times, meaning we have every type of material you can imagine, from all the Rogers 3 Series, 4 Series. We have all the Megtron, Meg 6, Meg 7. We stock all the Panasonic, Isola, and Selectro. We stock everything. And we stock also a lot of that up to 6-ounce copper where it's relevant. And we have all our temperature controlled stuff and everything all here in-house, because again, you can't be a quick turn board shop and have to wait 3 days for material. So we stock all of our popular materials and then some. And then, like, going back to the idea of not being bureaucratic at all, if you have a job and you know ahead of time, you say, hey, I'm gonna have a couple builds of these. Can you guys just buy and stock this ahead of time? And I'll even do my POs as they come in. That's fine. Like, we are totally flexible doing that. We can get good deals on material for you if we don't have it in stock, which is probably unlikely, especially for this user base. But a lot of our materials and all the ones that you'd probably use, we stock. Like, what are the common Rogers ones that you see generally people using?
Oh yeah, we have Rogers 4003, 4350B. Those are probably the most common two that we use. And again, that's used on a weekly basis, no problem. If not, sometimes daily basis. Always have it in stock.
I have another question from Ted. He's asking, does via fill help with shock/vibrations on the board?
Yeah, absolutely. You're putting something in that hole, and that hole can no longer cave in. So any type of shock or something like that going on with the board, you're going to have a lot more protection.
Yeah.
So I'm assuming that if you're using the board in an environment that is going to be kind of rugged, maybe something mobile like a vehicle or some sort of a balloon, a weather balloon or something like that, and then it's a good idea to do that then.
Yeah, absolutely.
Okay,
yeah.
Excellent.
We do a lot of boards for popular automakers, especially the cool ones in the Bay Area, and they have a lot of via fill on the boards. And one of the other things that he briefly mentioned, Elijah, was the copper via fill. That's something that we don't actually have a picture of here, and it's in one of the other later slides you'll see. We're one of, as far as I know, 2 shops in the country that can really do this. And this is literally a full copper filled shut via. And it's incredible for thermal conductivity and heat dissipation and all these other things that you're really looking for that weren't previously available, and they're still not at like 98% of shops. But we have the ability, we invest in the technology. We have a lot of customers coming to us and seeing great success with using it. What's the minimum size we're seeing right now for copper via fill that we're allowing people to use?
Minimum's around, I believe it's...
Or maximum, really.
Or maximum, where it's about 20 mils. Anything bigger than that, it's really hard to get the copper to get in there and stay in there. It's going to want to just ooze out.
But that's a huge hole.
A bigger hole. Yeah.
People doing it for BGAs and like kind of like really, really small holes, you still want to get that better thermal conductivity and heat dissipation. Copper via fill is a great way to go. It's a new technology. It's been proven. A lot of our customers really like it, and something that we can get more in detail in if you like and send more information out.
Yeah, definitely. And the tightest we can do is about a 4 mil hole, which is pretty good.
Yeah, with mechanical.
Yeah.
And laser drill can go even smaller.
Exactly.
Excellent. Thank you. I don't have any other questions. Let's move on. Go ahead.
Cool. Okay, so now this is more on the assembly side. I just wanted to make one brief comment on the actual bill of materials, because as much as everybody has a perfect BOM and their boards work, I mean, the stat that we ran over yesterday over literally thousands and thousands and thousands of quotes was 98% had some sort of mismatch, missing part, or error in their BOM. Now, whether or not that was a showstopper or a big issue, that's not part of the statistic, but more like it's hard to have a perfect BOM with everything. And so it'd be easier if we just told you what constitutes a perfect BOM, at least on a broad, high level. And it's really not that complex. You'll see all these things I wrote on the left, the, I guess, larger, more bold-faced, non-italicized headers are what you really need at a very basic level. And it's something that you can start early on in your design that I've learned through doing so many designs of my own. And it makes life a hell of a lot easier, even though it never ended up being what you actually did. You finish your design, and then you're like, oh God, I got to scramble. But basically, your part name, the quantity of that particular part, like part name meaning for each component, the manufacturer part number, and the reference designator as it relates to the board. Like, where is this part on your board, and how do you reference it? R9, C10, L5 for an inductor, whatever. So those are the main ones. And then you can go above and beyond, and it only helps by having the information below, like your distributor, part number, alternates allowed, because not, some parts may not always be available, and you didn't plan that early in your design, or you may not be, you may not know it at the time that something's been end of life or whatever. So just having that information there would be great. So that's kind of what we look for in a bill of materials, something that's pretty clean and simple, but you'd be surprised at how many people still don't send a complete bill of materials. And the more information you provide, the better. So now to briefly talk about how all the things that we talked about in terms of manufacturability, choosing certain types of vias, the right kind of tolerances, following design rules relates to manufacturability. There's a second level that directly correlates to that, and that has to do with cost. A lot of your design decisions can influence cost in a smaller, big way, but oftentimes it's like the smallest changes that can actually influence the cost in the most substantial way. And generally that has to do with how complex the actual manufacturability becomes. And that's something that isn't widely known. And we're working, especially with Eagle, to make that more a part of the design process. So as you're adding things in, you're kind of getting a sense of what's adding cost, what's adding time, etc. But just in general, so people to know, price structure for any board shop is generally done on the size, which relates to the size of the individual board multiplied out times your quantity. Really, it's just by panel, because every board shop in the world pretty much runs panels, right? If you have a board this size or this size, we're still running a panel. Make sense? So we're still running this whole panel, whether you just want 1 or 30. And we can panelize design. Like I said, we do a lot of work for Osh Park and customers like that, where they've already panelized designs, we panelize designs, etc. But just being aware of how things run through the shop, whether it's even a 2-layer or a 6-layer, it's pretty much the same process, excluding blind or buried vias. You still have to run it through all the same processes, through the factory, through the manufacturing floor, and through CAM and tooling. So it's still not like a quick drop. A 2-layer is that much cheaper than a 6-layer, or rather a 6-layer is that much more expensive than a 2-layer, because manufacturing is kind of similar. So size, speed, how fast do you want it? That's more of an intangible, but it has to do with how we kind of run and program the entire shop and move jobs around to make sure we're on time for everybody. We don't prioritize somebody over somebody else just because they paid more. And then the layer count, right? How many layers you have, and that directly relates to the number of lamination cycles, how long you're going to spend in presses, and how many people and machines and time it actually has to spend to get it built. And then you have the adders, which we'll talk about now, more like blind buried vias, via fill, material, etc. So I'll let Elijah kind of go briefly on what are some of the bigger, more substantial adders that we see that's basically beyond our standard spec. And all this information is available on our website. But just to kind of give a more specific overview on what really drives up price and manufacturing complexity in design.
Yeah, I think one of the biggest ones is going to be your blind and buried vias. It's just, again, you're turning one sandwich into 4 multiple sandwiches, and it's taking us a lot longer to be able to laminate those, drill those at separate cycles. Every step is going to have its own parameters that we have to follow now. So that's definitely going to be one of the bigger adders. Other stuff like via fills, putting epoxy in your holes like we talked about. It's going to be a little bit cheaper as far as filling. Once you get into those copper filled holes, that's going to be a lot more expensive because how much copper we have to put in there, the special tanks that we might have to use, stuff like that.
Yeah, exactly. Just kind of things to be aware of. And then on the assembly side, just choosing easy to source and easy to assemble parts. I mean, if you're going to choose a bunch of BGAs, that is a little more expensive than some passive parts or even some easy like TQFP microcontrollers that you might be able to choose for your design. If your package does certainly make a difference on manufacturability. And also thinking about yourself for these prototypes, ease of rework is a huge thing. If you can choose those 603, that's probably going to be easier to rework, especially without a microscope, than 0201 and things like that. And then just more on the actual design. If like you're at a business or if you have a bunch of different designs, it's probably smart to use common parts and common circuits. That way you have, a kind of similarity between the BOMs of your different part numbers and your different boards. That way you always have a nice stock, and the assembly shop doesn't need to buy 5 different parts and different shipping and time. So it's easier to do it that way and buy in bulk if you can. So is there anything else that you guys wanted to kind of get into on this side, on the cost?
There is. So your last comment is basically you're recommending to, if you have multiple designs, make sure that you consolidate your parts. That way you're using the same parts. That way you don't have to be changing it on the pick and place.
Yeah, it helps you.
Absolutely. Now, I have one question by Nick. He's asking, Is the conductive via fill process suitable for creating via in pads for BGA pads?
Could you repeat the question one more time, Ed?
Is the conductive via fill process suitable for creating via in pads for BGA pads?
Yeah, absolutely. We do that all day long. 99%, I would say, of micro BGAs are via filled.
Yeah, so I'm
Conductive
assuming that
filled,
he's referring to
non-conductive filled, or copper filled. We can do it all.
Yes, for the audience to know, a micro BGA is basically a via that is in the dead center of the BGA, and it usually could go down one layer, but we do have the capability of going further down if necessary. So it's basically a via, but it sits on a ball grid array pad, and it just basically takes that the connection that needs to go to that BGA and takes it to one of the internal layers. That's all it is. Just want to make sure.
Yeah.
That they know what micro vias is. And so the answer is yes. Well, okay, very well. I have another question here, but that's more for me, how the panelized boards in the Eagle Cam, and I'll kind of answer that towards the end. Okay. Okay, go ahead. Go move on. Let's go.
Okay. And so that was kind of it. And we still go into more like the DFM and the design for cost, but that's real big stuff, and understanding that there is a real factory behind all these nice things that you're able to do in the CAD tool. You know, boards still need to go through the shop. They run on a panel. So panelizing is a smart move because you could fit a lot of things in one process. It's for sure going to be a lot cheaper and a lot faster to get your boards done that way. So as far as choosing your manufacturer, this is something that most people, this is not, you don't learn about the business on this side, but it's something that at least having a good understanding at a high level of what you're going into and who you're speaking to can save you a lot of money and a lot of time down the road. And the biggest one is understanding how the processes are structured independently as businesses. So generally, you have a fabrication house. We're building the actual bare boards. So we're building these bare boards, essentially taking the copper, etching them on, making your patterns, stacking them together, drilling, etc. We're making your bare board, no components on them. Then you have assembly shops, which are basically places that just have pick and place machines and reflow ovens and stencil printers or inkjet printers, etc. And they're taking your components, taking the bare boards that you get from us, and they're soldering the chips onto it. And then you have what is probably the largest in this community, and most people probably use these folks unknowingly or even knowingly because it's oftentimes a good deal, but it's the idea of a broker. They don't have a factory at all. There's no specific fab house, there's no assembly house, but they're offering a service which usually has to do with customer service or the idea of panelizing a large number of orders that they're getting already, things that the fab shop and the assembly shop alone may be unable to do. So there's three different areas, but on the general scale, most brokers that you see, and the reason they even exist is because, especially historically, fab shops and assembly shops were hard to get in contact with, and assembly shops as well. Assembly shops also being commonly known as CMs, contract manufacturers, they're just doing turnkey, but they're brokering out the boards. And so it's oftentimes good to use them. But if you have a small prototype build, or if you're really kind of worried about the construction of your board or the price, it's oftentimes best to just go direct. Or if you're going to do full turnkey, start with the fab side, because that's where the real complexity and the cost of your board is going to be, not in the actual soldering of your 603 resistor. It's really on the construction of your board. So most CMs, they don't have a fab shop, right? The partner that we have is essentially our own assembly shop, and so they now in turn have their own fab shop. But most assembly shops, they're just sending out your files to 50 different fab shops, and they're at mercy of who has capacity, who has time, who's going to build it correctly. And if there's problems, I mean, God help them. So it's good to find people that are actually full turnkey, that have businesses in both sides, so you're not talking to someone 2 levels removed and having to worry about, why is my price going up? Can I talk to a CAM engineer? And you're talking to 2 different levels. Most assembly shops do not have a fab shop. They broker it, and they're marking up the price on the boards. So it can help you a lot to go direct and kind of know, do these guys actually have a fab? Are they running the processes in-house? Or are they brokering and outsourcing, and I'm meeting the cost? And that's very common, and just being aware of that can be very helpful. US versus China. China's getting faster. China's getting really good with quality. But there's a lot of reasons you still want to go here. One is protecting your IP. but two, it's the speed. I mean, you still can't get a same day or a 1 day turn in China. If that's the market that you're looking for quick boards, I mean, you're going to be a lot better and really only suited to go with a US shop, especially one that's in like kind of the heart of Silicon Valley and has a whole part of that process. And then also the customer service, the ability to actually just call a CAM engineer and work with us. That's stuff that we open our doors to and our phone lines to at all times. So being kind of knowledgeable on who you can reach out to, who's touching your design, where's it going, are they outsourcing it, are they brokering it, kind of being mindful of that. The shop that you choose, especially if it's a quick turn, especially if you're paying that premium for a quick turn, 1, 2, 3, 5 day turns, ask them, like, what equipment do you actually have in-house? Do you actually have your hassle finish in-house? Do you have your ENIG in-house? Do you have two of everything? What happens if your test machine goes down? What happens if your legend machine goes down? Am I going to eat the cost of that? Or are you going to not be able to deliver on time? Being aware of, is the shop actually running? Are they putting money back in the shop? Is this company growing year over year? And this isn't like a whole business lesson, but it's something that most people say it doesn't really matter, but then when your boards show up late and you still got to eat the bill and you got nobody to call, you don't want to be stuck in a bind. So the business that's financially healthy, that's putting money back in the shop, investing in its employees, that's a huge, huge deal maker in choosing your fab shop and somebody that's going to be supporting you all the way end to end. So that's kind of what the overview is. And how do you choose a fab shop? Mainly it's what actually do they have in-house, and do they have duplicative efforts on all their equipment? Are they upgrading their equipment? Do they have spare parts? Can they basically work on the fly and not just build my board quick turn, but build the factory backup quick turn? So that's what we're looking at when you're choosing your actual manufacturer. And then, were there any questions on that?
No, not really. I have only one other question is, if you ship to UK, do you do international shipping?
We do. We actually build a lot of boards for Circuit Hub. We work with all those guys, and then we have a lot of customers over in the UK. So we're totally comfortable shipping UK and overseas past that as well. But that's not an issue, and we can still build boards quick turn and ship it quick turn as well.
Okay, excellent.
For
That
sure.
was for Nick. And I have another question here, and do you work with anybody internationally, Mahir? Do you have any partner?
Yeah, so we generally like to keep everything in-house in the US, but there's sometimes when you have a mid or high volume run, and obviously with the customer's permission, you can get a much better deal and it just kind of gets out of the shop to do some high volume. Or if customers really, really request it and they're like, I don't care about XYZ, I just want dirt cheap. We can help them work with a shop in China and handle all the customer service still through us. So it's a lot easier for them. So we have contacts, and more than contacts, we have actual partners and shops in China and in Korea. So when China's down, Korea's up, Korea's down, China's up. So we have that. And then we have kind of some other overseas processes, but everything else is done in-house, including CAM, engineering, sales, production, assembly, fabrication, sourcing, etc.
Okay, excellent. Yeah, I've heard of we have a lot of users in the Europe area using Royal Circuits. Apparently they've been around for a very long time as well.
Royal Circuits is a great shop. We've actually built boards for them in the past for some of the more complex stuff, and we've helped them with some of their US customers as well. So they're a great shop.
Yeah, in Eagle you'll find the DRC files already in Eagle for Royal Circuits and some other board houses which are located in Europe as well.
Yeah.
Okay.
Exactly.
Also, there's a question here from John about panelizing boards in Eagle. And Eagle, there's not really a way of panelizing boards right now from our CAM processor. We basically, there's a way of doing it, and I will do a webinar based on that. But basically, you take the one board and you could create a design block of it and then paste it multiple times on one board and make a panel out of that. It's not the easiest way because it actually renames your components. But I'll do a tutorial on that later on.
Or you could send it to us,
Yeah.
and we could do it because you just send us your files individually as if they're individual boards, so you don't even need to deal with the drama. And then we'll just panelize it for you because we do that all day. We have our own panelizer software written. We do that in-house all day long.
Is there an additional cost for that, guys? Is there any additional cost? Is there any additional cost for that? For panelizing?
No, not really. I mean, it comes in. It's all part of the same quote. If you just send us your files, we'll just throw them on a panel. It's not like an additional cost for that because it's still going to be part of the same as far as manufacturing.
Okay.
And we generally don't charge for that ahead of time. I mean, if it's a super complex thing, you got 90 designs, we may have to do something custom. But generally, if you have a few designs, you want to throw them on a panel, that's fine.
Oh, that's even better then. That's even a better price.
Yeah.
Okay. And so
Yeah.
you don't have to do the whole thing in an Eagle then. So you could just send out the boards
Yeah,
and
just send it to us. We'll do it. And it's done because we actually do it DFM and we're doing it in the CAM. So you already save a step and you're saving yourself some time and effort, making sure it's done right with the right score mouse.
yeah, not all board houses offer the service. So make sure that if you're using any, so whoever you decide to use, just ask them. A lot of times they'll take the Eagle file and they'll take care of generating the Gerbers and panelizing. So you just ask them. I've learned of many other services that actually will do that for you as well. Okay, cool.
Yeah.
Yeah, and like Mihir was saying, just send us your one-up and maybe a short list of what thickness you might want to rail, how many you're looking to put up, if you want them in a specific 5 up against 2 or something.
Yeah.
And then any other specific dimensions you have. If you prefer mouse bites over scoring, again, scoring can only be done on straight lines because it's basically a saw that comes and cuts. But just send us your preferences, and if you'd like, you can always say, I want to improve that. And we'll send you the files back so that you can overlook them.
Excellent. Thank you very much. Greatly appreciate it. I don't have any other questions, Mihir. Do you want to go ahead and continue working on, give us an overview?
Yeah, so at the end, it's just really the overview of our business. Like I talked about, we do fab and we do assembly. Everything is done in-house. I mean, our real niche is in 1 to 3 days, low volume, high mix. So we're running all sorts of different boards of complexities, materials, stack ups, weights, etc., through the shop at the same time. And they're running smoothly, and we're really shipping things as fast as like literally 12 hours. I mean, for a 2-layer board, you can get it that same day. You pay and you kind of hustle, but it can be done. Our teams are ready to go. Our shop is running pretty much 24/7. Our phones are on all the time, and we're really 100% there for the customers. Like I said, we do rigid, we do flex, and we do rigid flex, all in-house. We don't broker any of that. We do all our surface finishes, all our plating. We even have, well, I guess more in the general idea of reinvesting back in the business. I mean, each year we're putting in almost $3 million cash back into the business just in equipment. Yesterday, we bought a $600,000 new solder mask kind of machine. We buy pulse plating machines left and right. We're kind of going to that new areas because there's more even plating structure and just a lot faster plating time. We have nano steam ovens, which are about 8 to 10 minutes of black oxide interlayer bake versus 1.5 hours, 2 hours for standard bake time. So we're just constantly seeing what can we do, purchase, research, build inside the shop to make boards of the highest quality, even faster, even better, in a higher quantity, et cetera. Just how can we keep pushing the envelope? And so we stock lots of material, like we said, and we're based in California. We have our huge facility that we're sitting in right now. We have 2 buildings here that does all our rigid boards. And then Los Angeles, we have a new factory that we just built. It's like massive, that does all the flex and rigid flex and the rigid boards there as well. So they're more niche down there, but they could still do everything. And then here we have our full rigid operation. And we also have our assembly here and over in Denver.
And I think something really quick to add to that, again, in choosing your manufacturer and the Royal Circuits overview, one big thing you're going to want to do is build a relationship with your board shop. There's so many things that can be answered in a quick email. And if it's somebody that I see really quick, I'm going to pick up the phone rather than answering an email and say, hey, here's the fastest way to fix your problem. Things like that. It just helps you so much more in the long run.
That's a great point. Exactly. Just building a relationship with the board shop. We're all accessible. We're real people. We're not just this backdoor, back office kind of old school, removed from the actual EE side manufacturers. I mean, we totally get it. We're all involved in that. We're right here in the Bay Area in LA and in Denver. So if you ever have an issue, come down to the shop. We're always open to having people for tours, and looking forward to kind of working with everybody and helping you guys build some awesome stuff.
Yeah, and definitely take advantage of some of the things that we offer, like stack up assistance. We have one engineer dedicated to just stack ups 24 hours a day. And you can call them at any time, even if you're not building your board with us.
Yeah.
Say, hey, I've got questions on my controlled impedance, or what materials I can mix and match, things like that, what tolerances I need. They're going to be able to help you out with that. And we have no problem helping you out.
And then, Ed, I know you wanted, the last thing I'll bring up is about PCBlayout.com. This is essentially, we've become like the fastest and the largest service provider for layout, where you can literally send in, just drop in your schematic. We'll even clean it up. We do footprint generation, and we'll do your full layout in like 24 hours, 48 hours for a price that about half of the fastest and the cheapest on the market today, which are some you'll see it's like less than 60, 70 cents per pin. You can get a layout done for like, not for a simple microcontroller, voltage regulator board, for like 50, 40, 30 bucks in a day or two with Eagle, and or we can help you with your design. We give you tips. We can help you do part of a design, all these other things. So we're offering kind of full turnkey service from layout to fabrication to assembly and all the way through.
Excellent. Thank you. Appreciate that.
Yeah.
Yeah, actually, and I had the opportunity to tour your shop a few years ago when I was in the area. I was going to one of the trade shows, and we drove down to Hollister over there to the.
Yeah, you got to come again, Ed. We're waiting for you, man.
Will do.
Lots changed. Yeah, so much has changed. Like,
yeah, the building
crazy.
in front was being built. It was still being built. The office building that's across the street.
Yeah, the office is being built. It was like a U.S. geological center, and we just bought it out because we have so many people working here. It's like a startup office in here on this side. It's awesome. The walls are painted like PCBs, and then right across the street, the whole fabrication side. It's awesome. We have a cool video on our website actually of a tour of both the buildings up here in Hollister.
Okay. Yeah, I think I did see that. Now I have a question here from John. It says, "What is Royal Circuits turnaround time on quotes, and can I upload Gerber files like Advanced Circuits and get a quote?" I'm pretty sure everything is yes. Yeah, everything is yes.
Yeah, on our website,
turnaround
time.
Okay. Okay.
And generally, we get all quotes, even if it's a crazy complex, like 16-layer stacked micro via buried blind board, within the day, usually within an hour or two.
Okay, so that takes care of your question.
We have people literally running 24 hours on quotes that are our own team, no outsourcing or brokering on that either, to service people just for quotes. And we do a DFM at the quote stage. We're giving you information back always, yeah.
So I have another question here from Peter. He's asking, do you offer some sort of a catalog of your preferred parts that you like to use, or it doesn't really matter? You don't have like a listing, have a list.
It doesn't matter because we don't really stock parts, because we, especially for assembly, you're talking about assembly, right? Like actual components.
Yeah. I think that he's asking for assembly. That's correct. Yeah.
No, we don't. And the reason for that is because our assembly side is such a high mix of boards. We couldn't possibly know what everybody wants to stock and do that. Yeah. Such a high volume of different customers ordering all sorts of stuff. We just build exactly what you need. So we save you money by just ordering exactly what you need. We don't need to buy overage like crazy big reels. We take cut tape, like I discussed. You can send us literally the exact amount, not in a reel, and we can handle it. We have our own systems to feed the pick and place, our special mechanical designs there. So no, we don't stock parts. Everything is fair game. And we will help you source and procure the parts at probably a cheaper and better price and faster availability than you might be able to. Otherwise, we can accept a consignment or a mix.
Yeah, I recently also learned that, if I'm not mistaken, you also do stencils, right?
Yeah.
Yeah,
we do stencils as well. We can cut those out for dirt cheap. That's something that we do. We found like a pretty innovative way to cut stencils at like a fraction of the cost that everyone else is doing. And we're going to start publishing and more promoting them in a large way, but here everybody can hear it firsthand.
Yeah, I was on a call the other day, and I just learned just recently that you do. I had no idea. I had ordered stencils somewhere else, and all of a sudden I learned that.
No. What we're planning on doing actually is just shipping them out with a couple orders. So just like make a note that you want one, and we can start printing them out. And like, I want to get more feedback on the quality, because right now what we've gotten is pretty amazing, and people are saying this is awesome. We're cutting them in record time, way cheaper, way faster than the traditional stencil guys of the whole factory kind of room set up for it. We just figured out how to do it.
Are you doing it on film or on metal, on aluminum, or what material are you using? Both?
So right now, pretty much, do you have one here? Yeah, grab it real quick. I'll show you a pretty cool stencil that we built for a panelized board. You can guess who it's from. Elijah's going to grab it real quick. But this is awesome. We should do more of these, Ed.
Absolutely. So he's asking.
Cut them out like that.
Oh, there you go. I see that. Yeah, I see that. I see that. Do
So,
you have a system by which you could frame them, or you only send the film, or can you frame them as well?
well, so generally we put like an outline around it that we already have set up in a program, so we can put like a small outline so you can
Okay.
tape it down and like run it over. Because for these small boards, it's hard to do exactly a replica.
Okay.
So we'll
Okay.
do
Cool.
that. But yeah.
So I have one. It's actually a really good question from John. He's asking, um, do you have a preference from the Gerber file or the Eagle file? Do you prefer the Gerber file? Do you have a preference?
If it is Gerber file, it's one less step for us, but it's honestly not a big deal at all.
Yeah, that's it. It's just we're going to convert it into Gerber for the most part anyways, because it's just easy to run through our whole system and floor. And even these other guys, so a lot of these newer CMs that you'll see that people go to, hey, the ordering's easy, take the CAD file. You know, all in the background, what they're doing is just converting it to Gerber. So it sounds like there's some revolutionary thing, but most people are just going and converting it and then running the same process and doing that manual work for you. Oh yeah, and then charging you on the back end for that.
Yeah, and I'll be honest with you, a lot of times the board houses have like a command line, so they just run the eagle.exe in a command
Yeah,
line format, and it's kind of a batch, and it just runs everything. It just takes them a second or less to make them.
that's essentially what we're doing. So yeah.
It's a command line, so that works. So I don't have any other questions right now. I greatly appreciate him here and Elijah for being with us. It was good information. I think our users will be able to have a better understanding when they're actually making the board, what's going on and what to
Yeah.
consider for different pricing structure. So I don't have any other comments. Not sure if any of our panelists had any comments. I don't see anything right now. Ed, did you have anything that you wanted to chime in if necessary? Okay.
No, that was great. Thank you.
Cool.
Okay.
Yeah,
Excellent.
hopefully you guys found it informative on DFM, on how to choose a manufacturer, what drives cost, what drives complexity. If there's anything else, you can always reach out to us directly. My email is just Mihir, my name, M-I-H-I-R at royalcircuits.com. Elijah's is Elijah, E-L-I-J-A-H at royalcircuits.com. Sales at royalcircuits.com also works just to get your files in, and we'll take care of you.
So thank you very much. Appreciate it, Mihir, Elijah.
For sure.
Thanks, everybody, for joining me here.
Awesome.